Hello everyone. Today we're going to look at quadratic inequality. So let's have a look at the first example where we have to solve the inequality x squared minus 6x minus 7 greater than 0 by sketching a graph. So firstly, when we look at this question, we would look at what kind of graph do we have. So here we have an x squared, which means this will be a quadratic graph. And for quadratic graph, we know the general shape would look like a U shape or would be an upside down U shape. So to decide which one it is, we have to look at the coefficient of x squared. So in this question, we have a positive coefficient in front of x squared, which is 1. So therefore, it will be a U shape we're looking for here. And to sketch the graph, I need to firstly factorize the left-hand side. So let's start do that. So my x squared minus 6x minus 7 can be factorized into x minus 7 bracket 9 times by x plus 1, which is greater than 0. So if we find out the root first, we would let x minus 7 equal to 0 and x plus 1 equal to 0. From that, we could solve to get x would equals to 7 or x equals to minus 1. Those will be the two roots of this equation. So now we can plot on the graph. So let's do a quick sketch. And we have minus 1 over here and 7 over here, and we know it would look like a U shape. So my graph will roughly look like that. And then we will look at the inequality, because here it says we want the graph to be greater than 0. Greater than 0 means we're looking for the part of the graph which goes above the x-axis. So we're looking at this end, which is on the left-hand side of the point minus 1, and this part of the graph, which is on the right-hand side of the 7. So you can see from the highlighted region that we're looking at two different regions on my graph. So when we describe using inequality, we have to use two inequality to describe it. So the one on the left-hand side, we can say that x has to be less than minus 1, or we could use the right-hand side, which will be x is greater than 7. So here's your answer. Okay, let's look at another one. Right, so let's have a look at the second example. Solve the inequality 5 plus 3x minus 2x squared greater than 1 minus 4x. So this inequality looks a little bit different to the one we just seen, because the other one we have seen, we have already got a 0 on one side of my inequality, which means I could very easily solve it to work out the roots. However, this one, we don't have the 0 on one side of my inequality, which means the first thing we could do is to rearrange this inequality and make it look like a nice quadratic equation first. So let's start do that, please. Okay, so what I can do is I could put my minus 2x squared in the front, and then plus 3x plus 5, which is greater than 1 minus 4x. And then I can put all the x together, so I have minus 2x squared. So here I would move the minus 4x across to the left-hand side, so I'll have the plus 4x, which means I'll end up with 7x plus 5, which is greater than 1. And finally, take away the 1 from both sides to get minus 2x squared plus 7x plus 4, that is greater than 0, sorry. Okay, so we could solve the inequality from that, and then we just have to deal with a quadratic equation with a negative coefficient. Or what we could do is that we could multiply both sides by -1. Now, if you do choose to do that, you have to be very careful that when we multiply or divide an inequality by a negative number, we have to switch the inequality sign. So let's do that. So we end up with 2x squared minus 7x minus 4. Switch the inequality sign, so be less than 0. Okay, now let's factorize the left-hand side. So we'll get 2x and x go inside the bracket first. We want something times together give you a 4, but then when we simplify, open the brackets, we'll get minus 7 in the middle. So we had to have a minus 4 and then plus 1. So now we have 2x plus 1 equal to 0, or x minus 4 equal to 0. So the equations together, two roots, we'll get x equals to minus a half, or x equals to 4. So by looking at the coefficient of my x squared, we have a positive 1. So now we have a U shape. And then we notice that we have a less than 0 in my inequality. So I have to highlight the correct region of the graph. So let's do that. So let's sketch my graph first and put the root on the x-axis at minus half and 4. And then we said we have a U shape. And we're going to highlight the region which is less than 0. So that would be the part of the graph which goes below the x-axis. And you can see this is a one continuous part. So we only need to write one inequality rather than two separate ones. So then I can say that my x value goes between minus a half and a 4. So x is greater than minus a half, and x also has to be less than 4. So that is our final answer. Right. Let's look at another question. So in this question, we have two inequalities. So we have to solve simultaneously the two inequalities. Now, the method is the same as the previous two examples we have seen, but we just have to consider the region later on, and this region has to satisfy both of the inequality. So let's start by solving the two inequality first. First one, we have x squared, which is less than 16. So I can move the 16 to the left-hand side to get x squared minus 16, which is less than 0. And then I will use the difference between square formula to factorize my left-hand side. So the difference between square formula says if you have a squared minus b squared, I can change into a plus b times by a minus b. So you can see here my a would be x and my b would be 4. So I'd factorize into x plus 4 times by x minus 4, which means our x plus 4 would equal to 0 or x minus 4 would equal to 0. So the two roots would be x equals minus 4 or x equals to 4. Now we can sketch the graph. This is a positive coefficient in front of x squared, so we have a U shape. And it cuts the x-axis at minus 4 and 4. The inequality is asking for less than 0, which means we want the region goes below the x-axis. So that means the set of value of x which satisfy this inequality will have to be x is greater than minus 4 and x has to be less than 4. So this is the solution for the first inequality. Now we have to look at the second one. Right, so the second one we have x squared minus x minus 6, which is greater or equal to 0. again, let's start by factorizing the quadratic expression on the left-hand side, and we'll get x take with 3 times by x plus 2, which means x minus 3 equals 0, or x plus 2 is 0. So that means the two roots would be x equals 3 or x equals 2 minus 2. So let's put onto our graph. So here we have a U shape because we have a positive coefficient in front of x squared. So that means my graph cuts at minus 2 and 3, and it will look like that. Okay, now let's highlight the region which we want. So we want the graph to be greater or equal to 0. So that's the two split areas. So that means for the left-hand side, I want my x to be less or equals to minus 2. Or for the right-hand side, I want my x to be greater or equals to 3. Now, when we have a few inequalities we need to satisfy, it's easier if we can draw it all on the number line, and then we can find the overlapping region. So let's do that. So if I draw a quick number line, and then I can put all the numbers on it. So I have a minus 4 here, and 4, and I want it to go between. Now here, there's no equal sign here, so that means I have to use an empty circle at the two ends. So I want this part. And then for the next one, I want x to be less or equal to minus 2. So minus 2 is here. And now I need a solid circle because it has the equal sign. And then less than means goes to the left-hand side. Or we could have x is greater or equal to 3. And we have a solid circle. Greater or equals to means when the region goes to the right-hand side. So hopefully you can see straight away from number line that the overlapping region will be from minus 4 up to minus 2, or from 3 up to 4. So that means the inequality which satisfy both, the region which satisfy both of the inequality will have to be x is greater than minus 4, but less or equals to minus 2. Or the other region, which will be x that is greater or equal to 3, but less than 4. And that is your final answer. Okay. Right, let's look at a final example. So this links with something we've just done recently. So in this question, we had to find the set of values of k such that the equation x squared plus 2k minus 5 equals 0 has no real root. Now, whenever we are trying to talk about whether an equation has 2 roots, 1 root, or no real root, it's linked with discriminant. Okay? And what is discriminant? Discriminant is b squared minus 4ac. So when we look at this quadratic equation, we need to first identify what is our a, b, and c. So they are the coefficients. So a is coefficient of x squared. So in this case, that's 1. B is coefficient of k. Oh, sorry, I missed an x here, right? So I should really put an x here. Sorry about that. Right, so b is the coefficient of x. In this case, that would be 2k. And c is the last constant, and in this case, that will be minus 5. So let's write down our discriminant, b squared minus 4ac. So that equals to 2k squared minus 4 times by a, which is 1, times by c, which is minus 5. And the question says it has no real root, which means my discriminant should be less than 0. So I want to set this to be less than 0. So now I end up with 4k squared plus 20, and that has to be less than 0. Now, I think there's a problem with this question, and perhaps I should change this. Right. I think the sign was wrong here. Okay, I think we need to start this again. Sorry about that. I think typo in my question. So I'll redo this question again. So we have x squared plus 2kx plus 5 equal to 0. And we want to show it has no real solutions. Okay, so my a equals to 1, b equals to 2k, and c equals to 5. So the b squared minus 4ac equals to 2k squared minus 4 times 1 times by c, which is 5. And I want to be less than 0. So that means we have 4k squared minus 20 less than 0. We can factorize the 4 out to get 4 bracket k squared minus 5, that is less than 0. And then we can divide both sides by this positive 4 to get k squared minus 5, that's less than 0. And we can use the difference between square formula to get k squared minus 5 could be factorized into k plus square root of 5 times by k minus square root of 5. So then we can sketch the graph, put the roots on the graph. So the graph cuts the axis at minus root 5 and the positive root 5. And if I want the region which is less than 0, so it goes below the x-axis, then that means that my inequality will have to be k goes between, so k is greater than minus root square root of 5, and k is less than square root of 5. So this is the set of value of k which satisfies the equation so that it has no real roots. Okay, so this is the end for this section, and I will send you of the exercise for you to complete. Please try the questions and use the answers to check the answer sheets to check your answers. And if you have any questions, please do email me. Thank you. Bye.